The microphone's loud? Well, I'm loud too. Kyle's a soft-spoken guy. So, here, I'll hold it farther away from me and maybe that will make it better. Okay. Our first speaker this morning is Kyle Dillard from Joplin, Missouri. Kyle is graduating this spring with a Bachelor of Arts in Computer Science and a minor in music, which you might have guessed from his seminar topic. And then he will be looking for jobs after that. Something interesting about Kyle is he was born in the same hospital as his mother. So that wasn't in Joplin, right? That was in Wichita, that's where you were born. There you go. Okay, and Kyle's going to talk to us about a music programming language named Chuck.
All right. Let's see if I can get this to work. Can everyone hear me? All right. Can everyone hear me all right? Good? Just a second. So, give it just a second. So yes, today I will be talking about Chuck, which is a programming language used to program music. So to give a bit of a background, mathematics and music have been shown to have a lot in common. Like for thousands of years, there's been known to be a link between the two. Several ancient philosophers have talked about the link. At one point in time, music was considered a major category of math. And even when it was no longer considered a category, there was still known to be a strong link between the two. Like music theory, for example, which is the study of how music works and its notation, involves a lot of mathematical concepts in things such as intervals, beat, rhythm, meter. All those involve numbers, so math is obviously very important for music. So this leads into another topic which involves math, which is computer science. Now obviously, computer science is basically founded on math. And a lot of the programs are written to solve mathematical problems. So with this, then comes the link between computer science and music. As in, those who are good at computer science are often also good at music and being able to recognize how it works. So that's why there are ways to combine both of them so that they can do things that humans normally can't do as easily. So that's why there are languages such as Chuck. So Chuck is a programming language used to create music in real time. It's free and available for anyone to use. So in this presentation, first I'm going to talk a bit about the background of the language with focus on the development of sound programming. And I'm going to talk about the transition to on-the-fly programming becoming popular. And I'm going to talk a little bit about the creator of the language. Then I'm going to talk about how the language works with focus on 4 topics, which are the Chuck operator, the precise timing model, the support of input and output devices, and the on-the-fly programming. And finally, I'm going to talk about some of the ways that Chuck has been used, including live coding and an iPhone app. So to start out, a bit of the background. Sound programming has been around for many years. It goes back as far as the 1980s. And it was made to do things that humans can't do with sound, or at least not as easily. Around the 1990s, PCs were continuing to improve in performance to the point where they were able to do things with sound creation such as this. And there were languages that were created for sound synthesis, such as Nyquist and SuperCollider. SuperCollider had a real-time ability which led to live-coded music, which I'm going to talk about in a moment. Around the time of the late 1990s and early 2000s, on-the-fly programming was becoming more popular. And this refers to being able to write the program while still running it, which is important. It was used in the SuperCollider language, which I just mentioned. And this language allowed for real-time synthesis and had a syntax like C and C++. SuperCollider, with all these features, allowed for live coding. And therefore, music could be created much faster in code like this. And this led to the inspiration to create Chuck. So now I'm going to talk about the guy that created it. This guy right here, named Ge Wang, at least I think that's how his name is pronounced, not quite sure, but he was born in China and moved to the United States, and he grew up with an interest in music. He learned to play different instruments while he was younger, and went to Duke University and studied computer science due to his father's suggestion of him studying a field that would be more applicable to the workplace. But even while there, he took several music classes to gain more of a knowledge on the subject. And when he heard electronic music, he became inspired to combine his two interests. So after graduating from Duke University, he went to graduate school at Princeton University, where he created several technologies that involved music. And one of these was Chuck, which was created in 2003. So how does Chuck work exactly? I'm going to give you a quick demonstration. So I'm going to show you a video of a laptop orchestra. And yes, there are orchestras that involve people playing music through their computers. So just watch this for a second, see what happens. So you may be wondering what just happened. So basically they were using devices hooked up to the computers to create music, and it was all running with Chuck. I'm going to give you a more simplified example. So here I have the interpreter of the mini article. Right here I got the virtual machine, which I will start. On the left here is the console. It says what's happening, and on the right here I have the main window. So I've written a simple program here to make sounds happen. I've made it produce, I have 5 sounds written here. I'm going to play in just a second. These 5 sounds are the 5 tones from Close Encounters of the Third Kind. So to make the sound come out, I simply need to click Add Shred. And just like that, it makes 5 sounds come out. So now that I've shown you a quick demonstration, I'm going to explain a little bit more how the language works. So basically one of the main focuses of the language is now. Now as a timing construct. What matters is what's happening now, the sound that's happening at this exact second. The program is strongly timed, which means that the programmer can control the time of sounds exactly as they want. Everything happens in a left to right sequence. In addition to the audio, there's also several graphics and video abilities of the language, but everything happens in real time, which means that it can synthesize the sound as the programmer is hearing it. So Chuck was basically founded on 4 ideas. First is the Chuck operator. Second is the precise timing model. Third is the support of input and output sources. And finally, on-the-fly programming. So first, I'm going to talk about the first rule, which is the Chuck operator. It is this arrow symbol right here. It's basically the heart of the language, as it is used in the vast majority of the commands. It comes from the term to chuck, or to throw something, which is where the language gets its name. Basically what it symbolizes is the arrow is a signal of it flowing from one side to the next. What's on the left side is usually referred to as the chuck-er, and what's on the right side is usually referred to as the chuck-e. So basically, it involves performing an operation on 2 or more entities. So for example, in my program, to create the first sound, here's part of what I did to create the first sound. The first line is creating a sine wave named S with TRIOSC. That's just one of the types of sounds that it can create, and it sends it to the digital to analog converter, or DAC, through the Chuck operator. This allows the sound to come out of the speakers or headphones, or whatever I choose to use. The second line sets the volume with s.gain. It puts the value of 0.6 into s.gain. The third line that you can see here is s.freq, which sets the frequency or the pitch of the sound. These are all important factors for creating a sound. If I wanted to use the same value multiple times, I could use data types just like in other languages. So in this example here, what I did in the language was put 0 into the variable silence, and I could use that every time I wanted no sound to play. I just wanted to pause. So there's several values that can be used in commands like this just to make things more simple. So now all that's important for creating sound, like making it come out of the speaker, setting the volume, setting the pitch, but none of that will make a sound happen without the second rule, which is the timing model. Time is very important in the language. Time is necessary for sound. Without time, there would be no sound, basically. So that's why many of the concepts of the language are based on this. First, I should talk a bit about shreds. You saw me click Add Shred to make the sound come out. Basically, shreds are like the synchronous building blocks of the program. They're basically like the processes that happen in the program. They're like threads in other languages in that they are independent and lightweight. They can operate concurrently, and they can share data with other shreds. Some of the differences, however, are they cannot be preempted by another shred. They also must voluntarily give up the processor for other shreds to run, and they're always implemented as user-level primitives. So basically what they do is they separate the program into sequences to make it better to understand. And they are all compiled and ran by the virtual machine, which you saw me start before I ran the program. So now how I controlled the time in my program was with the now command. I put the value of 0.25 seconds into now with the chuck operator. I did this after the sound to say that I wanted the sound to take place for 0.25 seconds. This command holds the current chuck logical time. It will always start at 0 when the virtual machine starts, and time will not progress unless the programmer specifies that it will progress. There are several time units that can be used in the language. Everything from SAMP, which is just a small fraction of a second, up through week. The language doesn't have month or year, however, because those times vary, but there are several different time units that can be used. If I wanted to use the same time, which I did in this program, I can also create a data type. Int and float and things like that won't work with time because it must specify the time unit. So that's why the dir command, DUR command exists. So I put 0.25 seconds into the variable of length, and then I can use that each time I want to use that value for a sound. Just another way to kind of avoid redundancy in the program. So now the third rule is the support of input and output sources. So obviously being able to input the commands into the computer and have the sound come out is important, but it's also good to be able to do more than just the computer. In the video I showed you, the people were using these kind of devices to control the sound how exactly they wanted. So Chuck therefore works through several physical devices, such as the mice, the keyboards, the game controllers, and many others. And it can work with several interfaces, such as MIDI, which is the Musical Instrument Digital Interface. This interface is common for input and output with Chuck. It was developed in the 1980s for communication between devices and has been used in the development of several types of electronic music, including modern dance, techno, house, drum and bass, and several things. But what made it stand out from other interfaces when it was released is how easy to access it was compared to others. It's become very popular among keyboard manufacturers to the point where basically any keyboard manufacturer will use it in the development of their synthesizers. There's also other input and output protocols, such as the Open Sound Control, which was developed in 1997 to fix some of the shortcomings of MIDI. This was built upon the connectedness of computers in the local area network and helped a lot in the development of live coding, which was very important. There's also serial, which is older than MIDI but is still in use today. And while MIDI is basically a form of serial, it's often considered its own thing. But these interfaces just show how useful Chuck is, and then the fact that it can be used with all of them. Finally, the fourth rule is on-the-fly programming, which basically means that the programmer can modify the program without having to restart the code. They can do everything while it's still running. Basically, a way to think of it is as if coding, composing, and performing are all the same thing. Like I mentioned earlier, on-the-fly programming was becoming popular around the time that Chuck was made. There were certain packages that were using it, including the Super Collider and JIT-lib, and this made it one of the goals of Gewang when creating the language, that it be able to do this, that it be able to be coded live. Now I said that there were 4 rules of Chuck, but if there were a 5th one, it would be to use the modularity of shreds to program on the fly. Again, you saw me click add shred earlier. This is very important for coding on the fly. The shreds are all controlled with the virtual machine. It runs in the user space, and the shreds can be implemented at the user level. New code can be added through the virtual machine interface or the main window. Now I should talk a bit about the interpreter or compiler that runs the code. Command prompt is one of them. It's simple and is the original application used to code Chuck in. It's also one of the oldest types of user interfaces. But one of the easiest and probably the most common is the MIDI article. That's what I was using earlier. It basically involves 3 windows. First, I wrote the code in the MIDI article window. I was able to start the virtual machine, which controlled all the processes, with a virtual machine window, which also showed its status. And then there was the console, which sent the message to the user, such as error messages or just the status of what's happening, and the user can also choose to output any message that they want. So now I'm going to talk about some of the ways that Chuck has been used. I showed you an example of the laptop orchestras. Often these are used with Chuck. The Princeton Laptop Orchestra was one of the first examples, which Gewang was a part of its formation. It started as an ensemble of laptop instrumentalists in a seminar class in fall of 2005. And it used Chuck when it was first developed. And they still perform to this day with Chuck. After Gewang graduated from Princeton University, he went to work at Stanford University, and there he still conducts the Stanford Laptop Orchestra. Now, the setup of these orchestras can vary. Princeton, for example, when it first started, had their performers using their laptop, probably either on their lap or in a stand right in front of them. They would also have a speaker hooked up to the laptop in front of each performer so that the sound they were controlling would come out of that speaker. Originally, they just used their laptop for the sound, but later other devices were added, such as the ones you saw in the video. Now, obviously, the setup can vary quite a bit, but Stanford and other laptop orchestras will use a similar setup, usually as this. There's several types of orchestras that have used Chuck. There's also been mobile phone orchestras. There's just been a wide variety of things. Another example that Gewang did was start the iPhone app company Smule with a student named Jeff Smith in 2008. Their first app was the Sonic Lighter, which was like a virtual flame that the user could light up and then blow out just by blowing into the phone. This idea was used for the ocarina, which is a simulation of the ocarina instrument. It involved the user blowing into the phone and playing the instrument with their fingers. This was developed with Chuck, and it can still be found on the App Store to this day using the language. So all this shows that Chuck is a useful language that can be used by anyone. It's open source and is completely free. It's a very succinct language, and anyone who's got a knowledge in programming with languages such as C++ or Java can use this, since it's very similar. There are advantages and disadvantages to using this compared to other graphical user interface programs. I mean, people can technically control sound with already created files, but this allows sound to be controlled much more precisely. So for anyone who can write and code, this is a very useful way to create music. So to conclude, Chuck is a language used to program music concurrently in real time. It was developed by Gewang in 2003 and was founded on 4 basic concepts, which are the Chuck operator, which is the arrow symbol, the ability to control time, the support of input and output devices, and the programming on the fly. It's gotten several uses, such as live coding in laptop orchestras and the Ocarina app. So all of this shows that Chuck is a great way for programmers to use their skills to create music. Any questions?
I've got one, Kyle.
Yeah.
So, does this have any interface to the normal way to represent music, like when you have a score and you write the note A, or you have to know that A is frequency 440 and you have to, that's the only way you can get an A?
There's different ways you can do it. The pitch is usually notated by a number. I don't know all the ways that you can do it, but I would, like, as you saw in the program, looked up interval ratios and what the numbers are for those, and I would change the pitch to that to be able to, I don't know, just have it go up whatever interval I did.
But there's no way to take something and convert a piece of sheet music and feed it into Chuck?
There might be, I'm not sure exactly. I have to look up. But there could be. Any other questions?
So the demo you gave us from the notes, it sounds very, very computery. And the videos that you played, it sounded just like a lot of noise. The music that you can create, would it sound like, violins, pianos? What would it sound like, or do you have control over that?
There's a lot of different sounds you can make. I use the TRI-OSC. There's also like square oscillator, sine oscillator. There's a wide variety of sounds that you can create in the language. That was just one of the sounds I did.
So the orchestras, though, do they sound like orchestras that have violins and cellos and whatnot, or does it just sound like computer music?
I've listened to some of them. A lot of them sound very computerish. I'm sure that they can make sounds that sound like cellos. I'm pretty sure I heard Gewang say that one of the advantages to programming with this kind of language is you can make sounds that normal instruments can't make. But I'm sure you can make sounds that sound similar to other instruments too.
All right, we're out of time, so let's thank the speaker.
Sorry.
Good job, Kyle. It should be the case.
While they're making the
Plug your
changeover, I got a quick announcement.
computer in.
2 of our upper level classes were closed yesterday, before yesterday. And that would be database and networking, and yesterday they got moved to a larger room so that we could up the capacity. They was shut off at 25, now they've been raised up to 30. They could actually be raised to 35 if they needed to be. So if you've been trying to add those classes when they were full, try it now. And contact me if you have any problems with any closed classes you're trying to add for next semester in computer science. Thank you.
All right. Our second speaker this morning is Abraham Morales. Abraham is from El Salvador and will be graduating this spring with a Bachelor of Science in Software Development and looking for a job after that. Something you might not know about Abraham is that he enjoys computer animation and doing special effects. Yeah. Do you have any special effects for your presentation this morning? A little talking. That's all right.
I don't know, it doesn't apply the same.
All right. Take it away, Abraham.
One, two. Can you hear me? All right, thank you. Okay, good morning. Today I'm gonna start talking about Flutter, which is a framework that you can use for cross-platform development. And I'm gonna start introducing this way. Wait, doesn't work. Yep. All right. When you're building an app, you will face some issues, or maybe no issues, but a circumstance when you need to consider several things. The first one is that you need to consider two platforms for now, which is iOS and Android. And it doesn't look like too bad at the beginning, but when you start considering all the things, like for example, if you make a team for this, it can be expensive. And also you need to consider that it will be two kinds of code bases, which is some point, at the beginning it will be a big deal. But as the app grows, yeah, you will have to make so many changes, and every little detail that you change, you have to do it for the other platform. And as well, it is not like just creating an app. Yeah, you can make it beautiful and very nice looking, but also has to have a good functionality. It doesn't have to crash, and it has to handle a good amount of users. So there are many things to consider, and not just the way that it's going to look at the end. Because people will like it at some point, but if they see a lot of issues, they will just quit and maybe install another app, or maybe just don't use any. So there are several options for this. The first one is creating with the native code. So you have Swift, Kotlin for Android, or Java as well for Android. And yeah, that will be the way to go, and yeah, no problem. But you have to learn two programming languages and all the things that you need to consider for those programming languages. But if you don't want to complicate too much, there are alternatives that have been around for years, such as React Native, Ionic, Svelte, Progressive Web Apps, or even Xamarin. But they do a pretty good job. At the end, you find you get the result that you want. But the way that they do it is kind of different among all of them. So a new solution for this comes with Flutter, and I will explain a little bit better to you what this means. And sorry, I just take my mask off. Flutter is an open source mobile application development SDK. It's created by Google. This is a good thing because Google is always supporting this project, and plus the community, which is, for now, it's not like too big because this project started in 2018. And yeah, I mean, it's pretty young, but the documentation for this platform is so good that you can understand it very easily. The community is very active, even when it's small. And currently, you can start programming an app for iOS and Android. There is also the possibility that you can work with this for web development, and in the future, they're planning to do it for desktop applications and even embedded. All this started as an experiment, and they just wanted to try if they can create a render engine that can run for 120 frames per second, and the results were pretty good. So now it became as a framework, and it's a pretty good choice if you want to do it for app development. Some characteristics that you need to see for this is a toolkit. At the end, you just remember that everything here is just a tool. You choose the right tool for your project. There is not exactly a right and wrong choice, but this will be a pretty good choice. And the set of tools that it gives you is you have the possibility to be very productive. It is very easy to start. Flutter gives you several tools and also like UI elements that you can start putting in your project without too much effort. So for example, something basic like a button or a menu. You don't have to complicate yourself how to create something nice looking like a menu. You just start using it, and you can modify it as well, but it's already done for you, and just use it. And it has a cross-platform approach. There are several tools, and those tools that I was mentioning, they are in a modern way. It's not like with no style and something that you will see, maybe I want to try something else. It's very fast as well. There are some little examples here where you can see that it's not bad at all. I mean, you can start from the beginning and maybe not change anything. Just put it as it is from the beginning, and it will start looking good. And then you can just focus more on the functionality, which Flutter is what you want to focus on. And if you want to be more creative, yeah, you can start creating something like that or even better. Some other characteristic is that it's open source and free to use. You don't have to buy or have a subscription to use it, as other frameworks does. And also have the idea of a single code base. When you are creating this app, you don't have to worry, oh, I'm going to create this for Apple, this for iOS, this for Android. And if you're talking about Flutter, you need to know a little bit more about Dart. And this is the programming language that it's using. It's also created by Google. And if you want to compare it, it will be basically like JavaScript, but for more user interface. There is a dilemma here when you want to create an app, because there is always this choice. You want to create something great and with really good performance, but you need to struggle with the code bases, with 2 huge teams for each project, that every change that you do, it has to be for the other platform. So, and also the issues for each platform, because you need to consider how it's going to look. You need to find consistency. And there is also the other way, when you don't have to worry all about that, but the results, they have like a price, if you can say that, because you're sacrificing performance, maybe the style, because it doesn't look the same in both platforms. And at the end, you don't get like the best result, but there is a third option with Flutter, because Flutter doesn't give you, oh yeah, it's gonna look good and you have everything done, and yeah, don't worry about the speed, but this time you are not sacrificing this. Why is this a solution? Because Flutter, in this case, has a combination of tools, like as you can see in this image. From the beginning, you can see that it is very good looking, and it has a good way to interact with the users. So compared with the other options, I mean, this is a nice choice. And also, you're not sacrificing the performance at all. As well, you're using Dart programming language, and Dart itself, as I was mentioning, is like JavaScript. Also, if you have programming C# in TypeScript or Java before, learning Dart, it will be very easy. And there's a saying that if you have programming in all kinds of these programming languages, maybe you already know Dart, but maybe you didn't know. So this is a good way to start considering learning Dart as a new option. But this is the secret. This is what makes Flutter different by using the render engine that is called Skya. Skya is a graphics render engine in 2D, but a fast render engine. You can render everything. You can render everything in the UI, so you don't let the other platform, for each platform renders your own UI. This helps you for 2 things. You will have consistency in how the app will look in both platforms, and it will be much faster. At the end, you will ask yourself, what's the difference? Because at the end, maybe you have been creating apps before, and you say, I mean, it's not a big deal because I have been creating my apps and I don't find any issues. But if you go beyond for something bigger, you'll need to start considering like the speed, or also the price or the time. If you are building the app for yourself, it will be a lot of time. And if for a team and you don't want to work with it, it will be too expensive. So in practice, Flutter is not very different compared with the other options, because all of those create the same thing at some point. But the way that Flutter does this is very fast, and that's the innovative part. Flutter renders its own UI with Skya, the render engine that I was mentioning, and that leads for a fast performance. There is an example here just by drawing a line. It's already done for the device, and it will be consistently the same in other platforms that you're going to use. And now, with the same dilemma that I was mentioning, now you don't have to worry that it won't be the best app. Now you can have a little beautiful castle as well, like something nice that you can start working, and it will look like you always handle the hard part. Compared with the other options, I mean, HTML, if you use HTML like with Ionic, you have to handle with two things, a bridge and a web view. The web view lets the platform, each platform renders what you want to show up to the user, and by using a common programming language like JavaScript, this is the way that React does. You have to communicate everything with your app, such as the location services, or the Bluetooth, or any other UI element. Like, this is not the case with Flutter. Flutter already renders everything for you, and that optimizes much better the functionality of the app. Of course, there are approaches. If you can handle this, you can just start doing native development. This is the most common way. So at the end, just remember that it's a tool. You choose the right tool for you. But you need to consider that it will be harder to maintain your project in the long term because of the project life cycle is something that you need to consider as well. And there is an advantage as well. You have direct communication with the UI elements. That makes it much faster as well. And for the cross-platform development, yeah, you have options like Xamarin, but it uses the web view. This is the easiest way. If you want to complicate yourself, yeah, you can choose this way, but it will have performance issues as the app grows. And with Flutter, it's faster. It uses a bridge. You won't find complications at the beginning maybe, but as the app is growing and requiring more things, yeah, it might get a little bit slower at some point. And Flutter, it will be, in this case, the exception because it's making a mimic of the look and feel of the app. And this is the game changer for this platform. Talking about Dart, the programming language for Flutter, let's get to know a little bit more about this. It's made by Google, so it's used to build the mobile desktop server and the web applications. It's more for creating the user interface, and it's up-oriented. If you experienced this before, maybe you're more familiar with this. And it compiles to native code. Even if you're programming in Dart, you can compile to JavaScript and it will look exactly the same. It's not like an interpreter. And it uses two kinds of compilations. The first one is just-in-time compile and ahead-of-time compile. The difference is like when you are working on the app, using the just-in-time compile helps you for debugging or working on this faster and have a better experience using the feature help reload. Help reload is basically when you're working on this and you already have your app open while you're working on it, you just make a change and in less than a second you will see it without closing it and opening it again. And when you have your application ready to be used, you use the ahead-of-time compile, and that makes it faster and also more responsive for the users. Dart also has support with the most common editors, which is Android Studio, VS Code, or IntelliJ. Developing with Flutter, it's very cool. For example, look at this image. This is a basic UI. You can see the image, a text box, maybe a stack panel, but it's not very visible. This is a common way to work with other platforms, but with Flutter, everything is a widget. So when you start looking more in depth here, the title is a widget, the stack panel in the horizontal way is another widget, the text box is a widget, and the image as well. So everything combined at the end is in another widget. That helps you for a better hierarchy, and you can know a little bit better where everything is. So, I mean, it helps you very well. And the amount of widgets are always increasing. You don't have to worry about something that you don't have, because in the future it will be as well. But even with the things that are already available for you, you can start creating like something like this, and it will look very nice. It also has a YouTube channel. Every time that a new widget is released, the team of Flutter makes a new video for this, and it makes it much easier to learn about it. And they are trying to standardize a new way to create apps by making material design. Material design is like a new normal way to start designing user interfaces. It's kind of the Google way, but different because it's the way that they do it. And it doesn't look bad at all. You can always change it if you want, but this is trying to be a new, different way to find a better consistency between other platforms, not just mobile development. And compared to the search results, Flutter, for now, seems to be in the lead for now. I mean, there is a little bit line that is going down, but maybe because of the coronavirus, people started looking for more things instead of just something like this. And Flutter came to stay. For now, you can see some advantages like a small community, or maybe it doesn't have a lot of resources, but it's growing. I mean, it started in 2018, and for example, React started in 2015. Maybe in 2 or 3 years, it will be the same or bigger than React. So we can start considering this as a better option, because it's not like the other options as well. It's also considering desktop applications and embedded. So I'm going to show you a little bit more about this with a code I created, an app. So this is the code, and this is the part that I was mentioning. Everything here is a widget, so you can see clearly here. It goes beyond, but there are more widgets. As long as you see more separation, it's another widget. And I separated this project a little bit more to understand it myself. But yeah, you just need to make sure that you link it with the main file. And also, you have separate folders for each project. For example, you can see there is one for iOS, one for the web in this case, and for Android. At the end, the result that you can get with this, it can be something like this interface, and it will look like JavaScript at some point, and it can be translated to JavaScript. Also, the same thing here, the same thing that you're looking here, it will look on any device, or even on the web or on your cell phone, because it's responsive. If you change the size, now you can see that you can do something like this, and now you open the chat, and here you have a new menu, a new functionality here. I didn't work on that, just to show more how the interface works, and some images here, a search box. So you can see that it's pretty good looking. And you can start creating this with Flutter. And if you want to start creating for mobile development or just web development, Flutter can start being a new option for you if you wanted to. But remember that it's just a tool. And just to finish, I don't know if you have any questions.
So, you mentioned about the Dart language that it compiles to both JavaScript and native code.
Mm-hmm.
Does it do native code for what kinds of processors? Is it good for every kind of processor that we would want, either in mobile or in desktop?
Yeah, because it's working with it translates to machine code, so it completes to the array processor. I read that it's commonly for the IRM processors, so it doesn't take a lot of resources.
Yeah, I just looked it up too, and it said that they do native for the ARM processors, but I was wondering about the Intel processors.
Mm-hmm.
Do you know?
I suppose that it can also work for those. I mean, if it can work with something that doesn't take too much, it can also work with something more demanding.
So the idea is that you can do cross-platform, including mobile devices like Android and iOS, but also desktop?
Yes, for now, it has been for just mobile development at the beginning, and now it's in beta for web development. And even for being in beta, I created this, and it works well. The future is for desktop applications, and then they are trying to focus on something more like in beta.
So the code is kind of hard to see because the font is so small, but it looked like there was this huge indentation, you know, like nested indentation. Can you tell us how that relates to what we saw in the interface? Like you pick out something in there and say, look, this thing right here renders as this thing right here in the user interface.
Sure. Like what part corresponds to what? Well,
Maybe your font bigger. Can you zoom in on the code?
oh, sorry.
Yeah.
This is the way that it will look. Can you see better?
Yes,
Yeah, I mean, you can declare the widget here, and then you start declaring some variables. And this is almost like HTML and CSS, when you can start deciding how it's going to look, the color it's going to have, the position it's going to have. And after that, you can start adding the content, like the image and some text. This is the part, for example, in here, when this is the part of the chat. So even if I just change it, I just save it, and you can have it there. It means everything in real time. And yeah, it's almost the same for every widget. You just declare how it's going to look, the position it's going to have, and the content.
These are all properties of the widget that we're looking at, and you list them in one big nested code construct. That seems to be the disadvantage, is that it's so nested like this, or it becomes a challenge. You got this, you even got comments. This curly brace closes this thing, and this curly brace closes that thing. And does that get kind of complicated?
It really depends how you program it. I decided to do it in this way. It helps me more, because even I use this for VS Code, and when I click on this, I know that it's going to end in that parenthesis that is highlighted here. It's just the way that you do it. It's just my way.
All right, let's thank the speaker. All right, next week we have our final seminar of the semester. So who do we have here? We have Pedro Navarrete and Don DeCastro. Oh, Donna! Hey, buddy!
I wanted to make sure if I explain myself, did I do it?
Yeah, I was just wondering why, it just seemed like it was really hard
To visualize?
figure widgets because everything's just nested. I mean, is that how most of the code looks like to create all your widgets?
No, it's the same thing like JavaScript, because it's just my way to understand everything in line. Because for me, when I just read it horizontally, it makes me search, and now I just guide myself with the letter that